This lesson will cover the derivatives of inverse trig functions. For our first function, we're going to start with the derivative of arctan of x, or the inverse tan of x. And we're going to start off by rewriting this by setting arctan of x equal to y. And then I'm going to rewrite this and say, well, that's the same thing as saying x equals the tangent of y. We're going to do this because we know the derivative of tangent. So we're going to take the derivative of both sides, and the derivative of x is simply 1. And the derivative of tangent, we learned before, is 1 over cosine squared y. But then we have to take it times the derivative of the inside. And derivative of y is simply dy dx. Now we can easily solve for dy dx. Oops. Here we go. Solve for dy dx by dividing by 1 over cosine squared y. So we've got 1 over cosine squared y. Or that's simply cosine squared y equals dy dx. Now that sounds like a pretty good derivative. The only problem is it's in terms of y, and we really want our derivative in terms of x, like the original function. And so that's where this triangle comes in place. We're going to take this statement right at the beginning that the tangent of y equals x. And we're going to recall that tangent is opposite over adjacent. And this right here, y, would be our angle. So y is our angle, and we know that tangent of y equals x over 1, and that's opposite over adjacent. So our opposite side is going to be x, and our adjacent side is going to be 1. Now down here what we're interested in is the cosine of y. So we know that the cosine of y equals, let's see, that's going to be opposite over hypotenuse. My opposite side, oh sorry, not opposite, adjacent over hypotenuse. My adjacent side is 1, and I need to figure out my hypotenuse. I use the Pythagorean theorem, so 1 squared plus x squared. Take the square root of that, and I can see that's going to simplify to 1 plus x squared. Now in this case, I'm not just interested in cosine y, I want cosine squared y. So I'm going to square this whole thing, and when I put it in here, I'm going to get that dy dx equals 1 over 1 plus x squared. And that is the derivative of our original function right here. The derivative of arctan of x is 1 over 1 plus x squared. All right, we're going to do the same idea here with arcsine. So same sort of notion where we're going to start off by saying, okay, let's set arcsine of x equal to y. We're going to rewrite this, so we're going to say, oh, well, that would be the same as x equals sine of y. Take the derivative of both sides. Derivative of x is 1. Derivative of sine y is cosine of y times the derivative of the inside, and the derivative of y is dy dx. Once again, we solve, so dy dx equals 1 over cosine y. And this might seem like it'd be the same as before, but our original statement was different. This time, we've got sine of y equals x over 1, and sine is opposite over hypotenuse. So this time the x goes on the opposite side. Y is still my angle because it's sitting right here. And 1 is my hypotenuse here. And so when I'm interested in cosine of y, which is adjacent over hypotenuse, I need to figure out this adjacent side. So Pythagorean theorem again, my hypotenuse squared, 1 squared, minus the other leg squared, square root of all of that. And so we can see that cosine is going to be adjacent, this whole thing, the square root of 1 minus x squared over the hypotenuse, which is 1. And so we get over here that dy dx equals 1 over the cosine of y, which simply was the square root of 1 minus x squared. So put that down here. And that is the derivative of arcsine. 1 over the square root of 1 minus x squared. All right, so your blue sheet that you filled out all the other derivatives you know, it's a great time to pull it out. You can pause and then start up this video again. And we're going to fill in these all where u equals a function of x. So we're going to be doing these with chain rule here. So In this first one, remember inverse sine was the one we just did, 1 over square root of 1 minus x squared. In this case, though, we're going to have u, and so we're going to have down here the square root of 1 minus u squared, and then we're going to take it times the derivative of u, and that'll end up here as u prime. For tangent, you'll recall that our derivative was 1 over 1 plus x squared. If it's in terms of u, it's going to be u prime over 1 plus u squared. And then lastly, you're probably wondering about inverse cosine. You will not have to memorize this, but occasionally it might show up. I'll show you that it's simply the negative of inverse sine, and I'll show you a quick explanation as to why that is. If we know inverse sine, we basically know inverse cosine. If we go to the previous screen here, we can see if this had been a cosine, we would have a cosine here. And the derivative of cosine is negative sine y. And all the rest of the math would turn out the same, except that you would have a negative right here. So that's the only difference between inverse sine and inverse cosine is the sign of the derivative. All right, so let's try these out and see how we do with some example problems. So here's our first one. We have the arctan of 2x. So if we want the derivative, remember the derivative of arctan, u prime over 1 plus u squared. The sooner you memorize these, the better. Derivative of 2x is simply 2, so that's going to go up there. And down here, we're going to have 1 plus 2x squared. Either you need the parentheses or you need to have squared it out. So either of these answers would be fine. All right, let's look at our next one. Give this one a go on your own. Pause and try on your own first. All right, welcome back. This time our derivative of the inside goes on top. That's just e to the x. And on the bottom, 1 plus e to the 2x. All right. Okay, try this one on your own as well. Welcome back. Same idea here. Derivative of the inside goes on top. So we've got cosine x on top. And on the bottom, we have 1 plus sine squared x. All right, here we go. Now we've got some arc sine ones, and you'll recall that this is u prime over the square root of 1 minus u squared. Give this a go on your own. All right, welcome back. So our first derivative on top, we have 3x squared all over the square root of 1 minus, and when we square that, that's going to be x to the 6th. All right, we've got another one here. Give this one a go on your own as well. Okay, so for this one, our derivative on top, remember we need to use chain rule with e to the 2x. So the derivative of the inside of this is 2. So we're going to have 2e to the 2x. And then on the bottom, it's going to be the square root of 1 minus e to the 4x, since when we square it, we can multiply the exponents. And then this one, give a go on your own again. All right, f prime of x equals, and the derivative of tangent, you can either write secant squared or 1 over cosine squared. Either one works. This just looks prettier. All over the square root of 1 minus tangent squared x. All right, so in this one, we should notice that this is going to be product rule. On your test, we had a lot of people who missed product rule. So I want you to give this a go on your own, see how we do on this. Welcome back. On this one, when we do this, we have e to the x squared left alone, times the derivative of arc sine x, which is going to be 1 over the square root of 1 minus x squared, plus the derivative of e to the x squared, remember, is going to be e to the x squared times the derivative of the inside, which is 2x, and then, of course, arc sine x left alone. And then here we've got another chain rule one, but the inside this time is arctan. Give this a go on your own, see how you do. All right, welcome back. Our derivative here, our outside function is squared, so we're going to start with this 2 arctan 3x to the first power. Now we take the derivative of the inside, which is where the derivative of 3x is 3. That goes on top here, all over 1 plus 3x squared. Probably in the back of the book, something like this would look like this in the end. 6 arctan 3x all over 1 plus 9x squared. All right, that should give you everything you need to know to do this homework. The big thing I want you to work on as you're working on this assignment is memorizing these two new derivatives and looking them up as little as possible. By the end of the assignment, you should have them down. Good luck.